Hello all, welcome to Excel Academy. So today we are going to study what I can say on the this one, that is endpoint DFT topic. So see here, you can see in the question paper whatever we discussed in the question paper, we saw the questions that is based on one is what I can say here, this one, which one, that is your 4-point DFT, and one question we saw with respect to endpoint DFT. See here, you can see there is a question on compute the endpoint DFT of the sequence x of n is equal to a to the power of n for 0 that is lesser than or equal to n lesser than or equal to n minus 1, right? Yes, so this is what we have seen. And in the other question paper, let me open the other question paper, students. Why I'm showcasing you all this question paper is because so you need to know first of all the basic thing idea, right? If I just directly say that endpoint FT questions is really important for exams, and if I start, you will just blindly believe. But I need to show the proof, right? I have to show the proof whether it is really important or not. So to showcase the proof, we are here with the question paper and you can see the question paper. So the questions are present, right? A 4-point DFT question and endpoint DFT questions are very important, wherein you can see in all the question paper it is present. And this question paper is for a syllabus only. I am repeatedly telling you. I'll also showcase you to that. Okay. Fine. I'll also club the two syllabus and then showcase to you. Fine. Right now only I'll do it. So see here, this is also one question on endpoint DFT, right? Yes. So, and if you take another question paper, let me take another question paper. Yes. So see here, here also it is endpoint DFT, right? See, this is also endpoint DFT, right? Yes, and if you come to the very last question paper, so first of all, before you know that any question is important for exam, you need to check with the question paper. Your question paper will only tell you how much it is important for an exam. All these are really important tips and tricks for you, because if you just blindly study, then you would lose, because uh, many people are in a dilemma that they don't understand problematic subject clearly. They find that difficult. If the case of the student is like that, so you people are supposed to, what I can say, learn all that without fail. You people are supposed to, what I can say, learn like that. That is, learn like that. In the sense, you have to, what I can say, have the important questions with you, and having the important questions with you, have to practice according to that, right? So, because for those kinds of students, it really helps you a lot. Because if you're not interested to study all the things, at least you can study the most important questions, or you can go according to the question paper, so that it would be really helpful for you, right? The one who finds difficult with respect to problem subject, their mantra is only this: they have to see the question paper, see all the important questions, and try to practice that more and more, so that they can easily pass the exam. If they're really not interested to study according to the syllabus, in the sense going in an order of syllabus, you can do like that, because problematic subject is a what I can say, a big mountain for many people, and they feel really difficult to, what I can say, crack that mountain, right? That is why I just tell you to do that, right? For the students who are suffering from that, they can do this particular by taking the question paper, by seeing the most important questions from the question paper. Try to practice that, go write your exams and give the best, right? Yes. And so see here, so this is also one question on endpoint DFT. So there are many questions on endpoint DFT, right? This is also one question, that is derivation on endpoint DFT. So endpoint DFT's questions are like, it is coming more and more in a question paper, right? There is one or the other question from endpoint DFT in a question paper. So endpoint DFT is most important. So most important in the sense, I say it as what? I say it as my super important. Just a minute, students. Yes, yes. Okay, so super important, I say. And now let me start with one question from endpoint DFT. Let me start with the simple, and then let's do all the question paper questions. So I guess the methodology is the same for endpoint DFT, because I have to substitute the values of it. So for cos and sin it varies, but for a to the power of n and all other questions, so you have to what I can say, it is like you have to substitute the values of n, right? Let us separate it based on substituting the values of n as well as doing it on another basis, right? Yes. So let me just write it as my question, that is your x of n is equal to, just a minute students, wait for a second, okay? So sorry for the distraction. So it is what I can say, that is 4 plus what I can say your cos square, and I'm so sorry. Okay, I am so sorry. It is what I can say, the cos square. It is cos square. What I can say, that is your 2 pi n by 2 pi n by n. Okay. Yes. So this is what is that particular question, and your n is equal to, given your n is equal to what? Your n is equal to 0. Just a minute. And one more update from yesterday's video. I have already told you in yesterday video. Wherever I have used it might have given the reason, because we don't know how the question combination will come, right? How the combination of questions from the topic will come, right? For example, yesterday we told you get a two question from electrical network, and another possibility is that you get a question from electrical network as well as block diagram reduction. That combination we don't know. He might give you any combination. And what many people will do here is, they'll just take one single question. What happens is, I've seen many students doing that, wherein they take the one who's really in need of passing the exams. What those students will do is that, so they will, what I can say, try to, what I can say, they'll just take only one single question from the question paper. That is, for example, for module 1 it is 1 and 2, right? For module 1 it is 1 and 2 question. Question number 1 and 2 comprises of module 1. So what the people will do is, they'll just take only question number 1 into existence, because what happens, many people will think that the order of the question will come the same, right? That is what that means is that, so see here, I'll just showcase you one question paper. So what happens here is that, so I'll just take another, because this is question paper is with respect to your this thing, that is your what I can say, the open choice question paper, I guess. Yes. Okay, so now here this is 1 and 2. This is comprising of module 1. Many people, or let me take other one, it is comfortable or not. Yeah, this one only I take. Okay, so what happens is that they'll just take this question paper, and they'll just think that let me study only question number 1, because in question number 1 he has asked you to compute circular convolution using DFT and IDFT for the following sequence x1 of n and x2 of n, and here he has given you to find out endpoint DFT, right? So what do people will do? Let me take question number 1 into existence. Let me study the two concepts from question number 1. Why? Because they think that this order will not change. For my question paper, this is another question paper, but when I am giving my exam, they think that for my question paper that comes, so we'll get this order only, like we'll get in the first 1A endpoint DFT only, we'll get it in 1B, in 1B we'll get circular convolution only. You will just think like that and go, but what happens, this is not the fact. See here it was given compute endpoint DFT of a sequence, and here it is given compute circular convolution, right? But if you take another question paper, see here, take this question paper only. So because after August this is only the next question paper, right? See here, what is this? See here, does the same question have come in one? No, you have got sampling of DT-FT of sequence x of n results in endpoint DFT, and you have got a 4-point DFT. What I can say, that is x of n is equal to 1001 using matrix method. You have not got an endpoint DFT question over here, or you have not got a circular convolution question over here, right? That is why don't believe in any single question and go for an exam, right? Many people do that. You'll think that the order will be the same. You don't know what order the question comes, right? See, this question might be in, just a minute, I'll just check it out. Okay, here hasn't given. So this question, which might be in what I can say the 2A or 2B, it might have come to 1B, right? If he's asking an 2A or 2B, he might have asked an 1A or 1B. The question combination will change. So please do try to study both the question with respect to module 1. Right? If you are seeing the question paper, try to study both the question with respect to module 1. Many people will think they'll only take only one single question. They'll practice that particular question. That is, in the sense, whatever the concept that have come from that particular question, they'll study that particular thing and they'll think that this combination will only come for exam. They'll have an idea. So in the 1A question, you'll get endpoint DFT as well as circular convolution. You don't get any other question in that 1A and 1B. That combination will only come for your exams and they will have an agenda and go for an exam. But that is not the what I can say this one. What? That is not your agenda. So you have to study the first question and second question also from all the question paper. So that whatever method you get, you are able to write it in your exams, right? The combination that is not your choice. The combination is not your choice. Combination is your examiner choice, right? The one who set the question paper, his choice is the combination. His combination is the choice, right? That is why he might give in any combination. See, he has given that endpoint DFT as well as circular convolution, but here he hasn't given something different. He has given the sampling of DT-FFT question as well as 4-point DFT using matrix method, right? That is why try to study all the questions for exam. That is 1 and 2 questions for exam without fail. If you are trying to see the question paper, try to study all the question. Don't go with the combinations. Don't go with the fixed combination. Try to find out the possibility of combination. Yesterday I have written and I have shared that photo also. I have written possibility 1. I have told that you get an electrical circuit question with a block diagram combination question, or you might get an two electrical questions, right? Two electrical circuit question, but those questions are compulsory, but the combinations are might, because we don't know what combination the question comes, what combination he might give. I also told you the possibilities there, stating that so this possibility will occur for you, or this possibilities will occur for you for sure. The questions are all the questions in the question paper are for sure, but the possibilities are might. We are just analyzing the possibilities and those possibilities will come for exam. So please do try to practice that. That is why I need to know combination of questions, right? Combinations of questions you need to understand on what combination the question comes, or like in the sense in this particular question paper he has given one theory and what I can say one, that is 4-point DFT using matrix method. Right here we can't predict the combinations. He can give on any combination. He might give you one theory question with circular convolution, or he might give you one theory question with what I can say the this one, that is a 4-point DFT matrix, or he might give you one theory question with the endpoint DFT problem. Like that you need to analyze the combinations and start working on the combinations of questions, right? That is what you are supposed to do. All the questions are compulsory, but the combinations is that you analyze, right? That is why you have to do that. I've seen many people doing that, and by that you will fail, right? Don't try to go with the fixed combination. Try to analyze different combinations of questions that come for exams, right? I now told you, he might give you one theory with the what I can say the 4-point DFT using matrix method combination. Those questions are compulsory, but combinations are might, right? Like that you have to analyze the combinations and start practicing without fail, right? Yes, that is what you need to analyze the question paper, right? Yes, you need not to just blindly see the topics and just study. You need to analyze the combinations also. Sometimes it might works for you, right? I've showed it to you in a clear manner yesterday. Please do try to understand, right? Now for this question, it is still n-1, right? All these are really important. Many a times your combination works out, right? Your combination works out for many of the question paper, right? Yes, for some of the question paper, the whatever the possibilities that we check, it is really helpful, because if you see the possibility of combination of questions that come for exam, that is A and B combinations of questions, so sometimes it might help you a lot, or it will help you a lot, because what happens is that in controls only I have told you two possibilities. If in two possibilities, any one of the possibilities, if it comes for exam, then you will be really helpful because you know what is the question and you have practiced. And if in those two combinations, if any one of the combination will come for exam, then you would really score good marks, right? Yes. That is why I told you to find out all the combinations, all the possibilities, how the question comes and study so that it would be helpful. Somewhat it would be helpful for you, and when you see the question paper, you would be really satisfied. That is why, right? Yes. For DSP, see, I showed you there is no possibility of combinations. You should know all the questions what that comes for exams, that is endpoint DFT, 4-point DFT using matrix method, formula method, circular convolution, and all the theory question that comes. You need to know this much and practice. So in whatever combination he gives the question, that is he gives one theory question or circular convolution, one theory question or endpoint DFT, or one theory question, or what I can say the circular convolution using concentric circle, a DFT IDFT method or a formula method, you have to be prepared, right? Yes. That is what when we were studying in our lower or PU also they used to tell, right? In this part, this question will only come here to practice. Like that, you have to go on, right? Yes. And for this question, this is really important. Please do try to understand. So please do try to understand what I am telling, and please do what I can say, do that without fail, right? Yes. Yes, so here what we're supposed to do is we are going to substitute till we are considering n is equal to 10. This n is equal to, we are considering 10 over here, and we are going to substitute till 9, right? For 10 it is starting from 0 to 9, right? Yes, 0 to 9. And now let me substitute now. So if I substitute my n is equal to 0, I am going to show you a separate calculator video for this. Okay students, yes. For n is equal to 0, so you have x of n is equal to, what I can say, the this one, x of n or x of 0, which is equal to, here there is something interesting, let us see that. Okay, x of 0 is equal to, okay, x of 0 is equal to 4 plus cos 4 plus cos square 0, which is equal to 5, because cos square 0 is 1, 1 plus 4 is 5. Anything into 0 is 0. So what is supposed to do? Cos square 0. What is cos of 0? Cos of 0 is 1, right? It is 1 square, right? Your cos 0 is 1. So 1 square is 1. So 4 plus 1 is 5. So as your cos is present, please to try to find out cos of that particular value. So here it is 4 plus, what I can say, so here if you substitute 0, so you multiply, if you multiply all this with 0, you get it as 0. So here now it becomes 1, right? This is cos square. I'll write the resultant value and I'll just showcase you the calculator part in a separate video, right? Please do adjust, because I can't show the calculator over here. It is something difficult for me. I just try to showcase you the calculator here itself, but it's not working. So let me showcase in a separate video, make you understand things. Fine? Yes. And here it is this. So you get a resultant as 4.6545, right? Yes. So now if I, what I can say, take x of 2, that is 4 plus cos 4 plus, that is cos square 2 pi by 10 into 2, right? My n is 2. So write my n is 2, and you can directly what I can say, write it as 4 pi by 10, or you can take it as what I can say, 2 5s are 2 2s are 5 pi by uh, 2, you get 5 pi by what is that, 2 pi by, what I can say, 5 you get. So if you do 4 plus cos square 2 pi by 5, you are going to get it as what? That is 4.0, what I can say, 959, just a minute, I am so sorry. Okay, and now my x of 3 is equal to the same. Okay, so I am not going to do further again because it is nothing. Here in the place of n, you are going to substitute values of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and here in the place of capital N, you are going to substitute 10. So that is why I am not going to do. So my x of 3, this value, or which all is having this value is x of 3, and what I can say, my x of 7 and 8, I told you what you have to do. You have to substitute here n is equal to 3, 4, 5, 6, 7, 8, 9, and here you are going to substitute n as constant. So that is x of 7 and x of 8 is having the value. Like this only you are going to write. You are going to write 4 plus cos square 2 pi into 3 by 10. 4 plus cos square 2 pi into 4 by 10, like that, right? X of 8. And now here 5 is having this 5. Just a minute, I'll just push it up. So 5. So which other is having a 5 is that x of 5. So x of 0 and x of 5 will have the value of 5. And this value will be taken by, so that is x of 4, x of 6 and x of 8. Okay, so it is x of 8, right? So this is what is all the things, right? So now we understood what is the problem. We have to substitute. We are going to consider as n is equal to 10, and we are going to substitute the values of what? We are going to substitute the values from n is equal to 0 to 9. That is small n is equal to, this is small n is equal to, we are going to substitute the values from the small n is equal to, we are going to substitute the values from 0 to 9, right? We are going to substitute the values from 0 to 9, and then what happens is that, so we are going to substitute the values from 0 to 9, and as capital N becomes 10 because we are considering it as a n point 10 point DFT, right? Yes. And if you substitute, you can see that for even numbers you are having the value 4.6545, and for all the odd numbers, yeah. Now for all the, this is x of 9 students, I'm so sorry. Yeah. For your, what I can say, by this you can say that, so what, by this you can say that, so your x of n, your small x of n is equal to, I'll also prove that, okay, don't worry. Yeah. Small x of n is equal to, what I can say, my x of capital N minus small n, right? Yes, how can I prove that? I'll prove it for 2 and all others are supposed to do, right? Why? Because I have already taught you these things, right? I'll already teach you now, and you have to work it for all the others it is the same. Because if for all the others it is the same, then instead of doing that, we could learn some new things, right? That is why. Fine? Yes. Don't feel bad. You can just write for all the others. See, with respect to your formula method, I have done for only one or two other things. X of 0 and x of 1 I have done, I guess. But please do oblige. Just like for all the others, it is the same process you're supposed to apply. So that is why I plan to, what I can say, just teach you things clearly and try to explain things in a clear manner, and make you know that for all others it is the same, so that you can just write without fail. I haven't done any half problem. I have made you understood the concept clearly well, and I told you that for all the others it is the same, so you can do it, and I've written the results also. Fine? Yes. If you learn for 2, you can do for all others, right? If you take x of 0 now, it is 10 minus 1. Just a minute, 10 minus 0. Just a minute, it is 10 minus 0, which is 10, right? So here we have not done for x of 10, so this is ruled, right? We have done till x of, what I can say, 9, right? Just a minute. Okay, so my x of 1 is equal to, I'll prove this without fail. So x of 1 is equal to x of, just a minute, x of 10 minus 1. So here I proved it, okay. X of 10 minus 1, which is equal to x of 9. I am so sorry. Okay, x of 9, right? Yes. So what was my x of 1? My x of 1 is equal to 4.6545, and I have taken my x of 1 as x of 10 minus 1, which is equal to x of 9. So see, I have written x of 9. My x of 9 is the same? Yes. That is why I told you this is this x of n is equal to x of small n is equal to x of capital N minus n. So x of 1 is equal to x of 9. I told you this 4.6545 value you get it for x of 4, 6 and 9. See here you got the value for x of 9 as 4.6545, and that is also the result for x of 1. So now my x of 1 became equal to x of 9, right? For all others it's the same. Like if you take x of 2, x of 10 minus 2, right? It is x of 8, right? So see my x of 2 value is 4.09549, and this value you get the resultant for x of 3, 7 and 8. I proved that x of 2 is equal to x of 8, right? I'll even showcase you in the calculator. Yes. So this is what is the one. And one more thing is that, so your cosine is an even over here. What? The cosine is an even. So therefore it is x of n is equal to, just a minute. Okay, x of n is equal to what? Your x of n is equal to, that is your x of minus n, right? Yes. So now here, you can see that, so just a minute, okay. So now you got to know by this too is that it is a real and even sequence. So x of n is what? Real and even sequence. So therefore for this real and even sequence, your DFT is given by, that is x of k is equal to, that is summation of n minus 1 to n is equal to 0, n minus 1 to n is equal to 0, that is x of n into x of n into what? That is cos 2 pi kn, cos 2 pi kn by n, okay. And this x of n, we know what is that, so we have to substitute that. It is n minus 1 to n is equal to 0, that is what I can say, 4 plus cos square, kn by n, 2 pi n by n, I'm so sorry, k is absent, yeah. Okay, 2 pi n by n. So that is what I can say, the whole bracket into what I can say, the cos 2 pi k n by n. Right? Yes. Okay, so this is for your, just a minute, yeah, this is for your 0. The condition is for your 0, that is lesser than or equal to, what I can say, k lesser than or equal to n minus 1. Or you can tell it as for k is equal to 0, 1, 2 to n minus 1, right? This is what is the resultant. So this is what is for that problem. And see here, so here the question given us, that is 4 plus cos square 2 pi n by n. So for that, what I supposed to do is you are going to take your n is equal to 10 point DFT, and you are going to substitute the values from 0 to 9, and then after substitute the values from 0 to 9, you are going to get all the values. So these values are repeatedly occupied by x of 4, x of 6 and x of 9, and this value is repeatedly occupied by x of 3. I'm so sorry, x of 3, x of 7 and x of 8, and now we also got to know that my x of n is equal to x of capital N minus n, and we have proved it over here, and I'm going to showcase it in calculator once again. And now, and we also got to know that our cosine is even sequence, so therefore we get x of n is equal to x of minus n, and here you can see that the given sequence is real and even, so therefore that is why for that you get an equation like this, that's x of k is equal to summation of n minus 1 to n is equal to 0, x of n into cos 2 pi kn by n, or which is equal to n minus 1 on n is equal to 0, that is 4 plus cos square 2 pi by n, so which is into cos square 2 pi kn by n, so wherein which is equal to, or k is equal to 0, 1, 2 to n minus 1. So this is what is you get a resultant. So here you got to know only one thing, that is you have your x of n as real and even, right? Your x of n is real and even, so therefore you are going to write an DFT for the such sequence. So the DFT for the sequence which is real and even is this particular, and for this particular you are going to substitute your x of n, right? Yes, this is what is for today's lecture, and I'm going to show the calculator part in the next session, and I'm going to leave the video, and thank you.